Inside a sealed bay at Gigafactory, Texas, a press the size of a house slams down once and a car's entire underbody exists. No welds, no hundreds of stamped brackets bolted together one at a time. Just liquid metal forced into shape in under 60 seconds. That machine is real, it's running right now, and almost nobody outside the company understands what it's actually for. Here's the part that gets buried under every headline about BYD stealing market share. The single most expensive station in a normal car factory isn't where the battery goes in, it's the paint shop. A chemical bath and a bake oven long enough to park a football field inside, built to coat sheet metal nobody will ever see once the doors close. Every car maker pays for that station on every car, whether it's a $90,000 sedan or the cheapest compact on the lot. And if you've ever priced a car and quietly closed the tab because even the affordable trim wasn't affordable, that station is a big part of why, not the battery, the building. So here's the question worth sitting with. Tesla promised a $25,000 car for years. In 2024, reports said that promise was dead, killed off for a driverless robot taxi with no steering wheel and no pedals. Was that true? Or did the affordable Tesla just get absorbed into a machine built to make it cheaper than anyone thought possible? Stay with me because the answer isn't a straight yes or no, and it's about to get strange. Subscribe before we go further. For almost 20 years, Tesla ran on one strategy: start expensive, then get cheap. The Roadster's high price funded the Model S. The Model S funded the Model 3 and Model Y, the first Teslas built for real volume. Elon Musk published this exact plan in 2006, and Tesla followed it step by step for over a decade. The final stage, the one everyone waited for, was the truly cheap car. It had names before it had a shape. The press called it the Model 2. Analysts called it the Model Q. Inside Tesla, it was Project Redwood, and for years it stayed exactly where affordable EVs tend to stay, always a year out, never arriving. That delay was tolerable when Tesla had no real competition at the low end. It stopped being tolerable the moment BYD did what Tesla never did. BYD didn't build a luxury brand first and work its way down. It built its own battery cells, its own semiconductors, its own motors from day one, and used that control to sell a car like the Seagull in China for under $10,000, while Tesla's cheapest car in most markets sat north of $35,000. BYD was already moving over 1 million vehicles at a price Tesla wasn't even competing in. At the same time, Tesla's own lineup hit a wall. The Model Y was the best-selling car on the planet, but by the mid-2020s, sales in key markets like Europe dropped by more than 40% in a single year. That's not a company losing to a rival. That's a company running out of people who can afford what it's already selling. To reach the next wave of buyers, the price had to come down by half, not by a few $1,000s. And here's the actual villain of this story, and it isn't BYD, it's a piece of infrastructure that's been sitting inside car factories since Henry Ford built the first moving assembly line. One body shell moving station to station, worker to worker, in a straight sequential line from raw metal to finished car. Every vehicle passes through every expensive station, including that oversized paint shop, no matter how simple the car is supposed to be. It's why cheap EV and profitable EV have almost never coexisted. Tesla's own numbers make the problem obvious. At its 2023 Investor Day, the company set a target of 20 million vehicles by 2030, up from 1.8 million in 2023. That's not achievable on Ford's line logic, no matter how many factories get built. So, instead of trying to make the old process cheaper, Tesla's engineers tried to replace it entirely. That replacement is called Unboxed manufacturing, and the idea is simple to describe, even if it's brutal to actually build. Instead of one body moving through one long line, the car goes together in separate sections at the same time, in separate parts of the factory. The front structure comes together in one zone, the rear structure in another. The floor, which now doubles as the battery pack itself, is built as its own flat, open module, with seats and wiring dropped straight onto it while there's still nothing in the way. Only at the very end do these finished sections meet and lock together, almost like snapping together pre-built blocks. And because individual panels are painted before final assembly instead of after, that massive dip and bake paint shop, the single most expensive station in a traditional plant, effectively disappears from the main line. Tesla says this cuts factory floor space by more than 40% and could cut manufacturing cost by roughly half compared to the already efficient Model Y line. That number is the whole story, not a slogan, a structural answer to a structural problem. If you can build a car in 6 pieces at once, instead of 1 piece at a time, and skip the most expensive room in the building for most of the process, the cost of cheap changes completely. But unboxed manufacturing doesn't work as a layout trick on its own. It only functions because of 3 other changes happening underneath it, and each one removes weight, cost, or complexity that the old assembly line simply had to absorb. The first is the giant single-piece casting itself, the same one from the opening of this video. Instead of stamping and welding together dozens of smaller steel panels to form the underbody, one machine injects molten aluminum into a single mold and produces the whole structure in one shot. Fewer welds means fewer robots, fewer failure points, and a lighter, stiffer chassis than a stitched-together one could ever be. The second change is the battery pack itself. In most EVs, the battery is a heavy sealed box, built separately then bolted underneath the car as one more component. In this platform, the battery cells are bonded directly into the floor structure, so the pack isn't sitting inside the chassis, it is the chassis. That single change removes an entire layer of brackets, mounting hardware, and structural steel that used to exist purely to hold a battery box in place. The third change is the most boring sounding and probably the most important for cost. Cars have run on a 12-volt electrical system for roughly 60 years, the same low-voltage standard used to run headlights and door locks since before most current car buyers were born. Tesla's newer platforms move to 48 volts instead. Quadrupling the voltage means the same amount of power can move through a wire carrying a quarter of the current, and less current means the copper wiring running through the car could be dramatically thinner. On a car with hundreds of feet of internal wiring, that difference alone strips out real weight and real cost before a single body panel goes on. None of these 3 changes is dramatic by itself. Stacked together underneath a factory that already builds in 6 pieces instead of 1, they're the difference between a $25,000 car being a marketing number and being an actual balance sheet. By early 2024, suppliers were reportedly being told to prepare tooling. A production start was rumored for mid-2025. Then, in April 2024, Reuters reported that Tesla had canceled the $25,000 car outright, shifting the platform's resources toward a fully autonomous robo-taxi instead. The market reaction was immediate. Tesla's stock dropped. Investors who'd bought into the promise of a mass-market EV felt like they'd been handed a science fiction gamble instead. Musk posted the report was false, but notably never denied the core detail. The low-cost consumer car, as originally planned, was not moving forward as its own separate vehicle. What actually happened, based on what's leaked out since, is closer to a merger than a cancellation. Tesla didn't kill the cheap car, it fused its fate with the robotaxi. Both vehicles, the driverless Cybercab and the consumer-facing Redwood, are built on the same next-generation platform, the same unboxed assembly process, the same structural battery floor, the same lower-voltage electrical architecture. The Cybercab has no steering wheel and no pedals, and it isn't meant to be sold to individual buyers at all. It's meant to run in a Tesla-owned fleet, generating revenue per ride instead of per sale. Redwood is the version you'd actually own, sharing nearly everything underneath the skin. By developing them together, Tesla cuts the engineering bill for both in half. That's the twist the hook promised. Not canceled, split into 2 vehicles wearing one skeleton. While that platform gets built out, Tesla needed something to hold the line against BYD immediately, not in 2027. That's where a quieter, less dramatic strategy comes in. Late in 2025, Tesla began rolling out stripped-down, standard-range versions of the existing Model Y, using cheaper battery chemistry and simpler interiors to push the entry price down on a production line that already exists and is already paid for. It's not the real answer, it's a stall tactic, buying time while the harder engineering problem gets solved in Texas. As for what Redwood will actually look like, the leaks point to a compact crossover, not a shrunken sedan, with sharper, more angular styling borrowed from the Cybertruck rather than the rounded look of the Model 3. The battery chemistry is expected to be lithium iron phosphate, cheaper and more durable than the nickel-based cells in Tesla's pricier models, trading a bit of range for a lot of cost savings, with real-world figures in the 250 to 300-mile range for the base version. Inside, expect a single central screen, simpler materials, and none of the extras that pad the price on higher trims. Analysts largely expect a starting price closer to $28,000 to $30,000 once destination fees and taxes are added. Not the exact $25,000 headline figure, but still a meaningful break from where Tesla's lineup sits today. None of this is guaranteed to work. The unboxed process has never been proven at true mass production scale, and a single misaligned module late in assembly can, in theory, stall the entire line the same way one bad weld could stall Ford's. Tesla already knows what that kind of failure looks like up close. The Model 3 ramp-up in 2017 and 2018 pushed the company to the edge of bankruptcy over problems far smaller than replacing the entire assembly method itself. This time, the platform is new, the casting process is new, and the wiring architecture is new, all at once on the same vehicle. And because Redwood shares its foundation with the Cybercab, its success is now tangled up with how well Tesla's self-driving software actually performs in the real world, not just in demos. If full autonomy stalls against regulation or unresolved edge cases, the two vehicles don't fail independently. They were built to share engineering costs precisely because they share a platform, which means a serious setback on one side doesn't stay contained to one side. There's also the question of whether a car engineered this aggressively for cost can still feel like a Tesla once someone is sitting inside it. Buyers forgive rough panel gaps on a $90,000 performance sedan. They tend not to forgive the same thing on a car they're comparing directly to a well-built Corolla. So the honest answer to the question this video opened with is neither yes nor no. The $25,000 Tesla wasn't canceled, it was absorbed into something riskier and, if it works, considerably more powerful. One platform trying to be both a robot and a family car at the same time. Whether that turns out to be a masterstroke or the moment Tesla overextended itself is still an open question, and it's one that won't be settled by a press release. It'll be settled on a factory floor in Texas, one module at a time. What do you think actually rolls off that line first, and will it be worth the wait? Thanks for watching.